Next we will see how to solve Newton's method making use of looping structure. Newton's method, also known as Newton-Raphson method, named after the great Isaac Newton and Joseph Raphson, is a root finding algorithm which produces successively better approximation to the roots. The idea is to start with an initial guess which is reasonably close to the true root, and then to approximate the function to get a better solution. The approximation function you will be using is, we start from x, we need to find the square root of a, x is a reasonable estimate of the root of a, then we will be finding the new root as y, which is equal to x plus a by x divided by 2. This is the approximation function we will be using and is specified in Newton's method, y equal to x plus a by x by 2. You will repeat this until a reasonable approximation is found. A reasonable approximation, that is important, because we need to run this loop until the change in the value of y compared to the x will be updating x each time will be small. So, this can be explained with an example. Consider the example where a equal to 4 and x equal to 3. We will be taking estimate of the root of a as 3. The actual root is 2. So, x equal to 3, then we will be finding out y equal to x plus a by x by 2, which we will be getting as 2.166. Next, we will be taking x equal to 2.166 and y equal to, again calculating y equal to x plus a by x by 2, that is y equal to 2.0006 some value. Then we will be updating the value of x as this and again calculating y. Value of y will become 2.000. You can see that the value of y is converging to 2, which is the correct root of a, that is 4. So, when you are writing the program, what you need to do is, what you can do is, you can take the difference between x and y. The difference between x and y is less than some very small value, say 0.00001, then you can break from the loop. So, we will see a program that does this. In general, we don't know ahead of time how many steps it takes to get to the right answer, but we know when we get there because the estimate stops changing. So, for that, our logic is, we will be exiting from the loop when the difference between y and x is very less, or we will be taking the difference, and if that is less than a very small value, then we will break from the loop. So, the program is a equal to float, we need to define it as a floating value number, a equal to 4. our estimate. We will be starting from the estimate x equal to 3, initial assumption x equal to 3. Then we will be defining a very small value epsilon, which is equal to 0.0001. This will be used to find whether the difference is very small. Then we will be writing our loop, that is an infinite loop. So, we will be writing while true. So, this loop will always be true and it will always be running. It is an infinite loop. So, if you wanted to write an infinite loop, you need to write while true. Then you need to find out the value of y equal to x plus a by x divided by 2. Then you need to find out the difference. The difference is very small, then you can stop. So, if the absolute value, you need to take the absolute, otherwise you will be getting negative and positive. Absolute value of y minus x. So, you can write either x minus y or y minus x, which is less than small value. In our case, we define the small value as epsilon. If absolute value of y minus x is less than epsilon, which means that the difference is less than 0.001, which is there is small, very small difference. So, in that case you can use the break statement which exit from the loop. Then you need to, if that is not the case, you need to assign x equal to y, then you need to continue this, you will be finding y, then you will be again taking the difference and checking whether difference less than epsilon, likewise. So, if you exit from the loop, when you exiting from the loop, the condition is the difference is very small. So, if you exit from the loop, you will be printing the value of y. So, if you run this, you will be getting the value of y as 2.0000 some value. So, if you increase the value of epsilon, you will be getting a better estimate. So, if you decrease the value, you won't be getting that much a better estimate. So, next we will see how to write something like this using a for loop. Again, a equal to 4, x equal to 3, which is our estimate. So, assume that we need to, instead of breaking from this loop, you need to run this for some 10, 100 or 1000 steps and exit. So, in that case you can write for I in range 0 to maybe 100. So, this will be executed 100 times starting from 0. Then you will be finding y equal to x plus a by x divided by 2. Then you will be switching the values x equal to y. So, this will be get executed and you will be printing the value of y. So, you will be getting 2. So, if you execute this loop 100 times, you will be getting a good estimate, but if you execute this for some 3 times, you can see that this is not that good. So, if you increase the number of times, you will be getting a better estimate. So, you can use for loop if you want that many iterations, or you can use a while loop to solve the Newton's problem. So, this is all about looping structure.